Hey, in this class we're going to look at the quadratic formula. So first you might ask, what is it? It is a formula that I have down here. Okay, now you might ask, what is it used for? It is used for finding the x-intercepts of a quadratic function. So let's say I give you a function. It has to be quadratic because it's called the quadratic formula. So the function, let's say, is a curve that looks like this. And you want to find where the x-intercepts are. There's always going to be two of them or one of them. We'll get to that later. But to find these x-intercepts, you would use this formula and plug in the values of a, b, and c. Now, okay, you might ask, what is a, b, and c? I'm actually going to give you an example here. So let's say I give you the function f of x is equal to 2x squared minus 4x plus 3. Okay, so in this case, your a value, so you have a, b, c. Your a value is always going to be the first number that is attached to the x squared. That is always going to be your a value. Your b value, pretty simple. You could probably guess this, but your b value is going to be the number attached to the x. So in this case, it is negative 4. Not just 4, you also have to look at the negative sign attached to it. For c, it is the exact same thing. It is a number at the end without an x. It is a constant at the end of a quadratic formula. But that's pretty much it. That's all you need to know to find the x-intercepts of a quadratic function. But then you might ask, what is the plus minus? That plus minus, what it tells you is that first, you're going to have to add the value of the square root. And then to find another answer, you're going to have to subtract the value of the square root. And that's why you're going to get two values for x, because you have two x-intercepts. One needs to be added, and then the other needs to be subtracted. So let's move on to a few examples of me showing you how to actually do this. Okay, question number 1. So first, before you do anything, you're going to need a calculator for this, because there's no other way of doing this. And you're also going to need to memorize the quadratic formula. I'm going to write it down here because this is video, so you don't need to memorize it for now, but if you want to do this on a test, you have to memorize it to begin with. But yeah, so the formula says that x is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. I'm going to make the square root a bit better, but yeah, so that's the formula. So first you have to ask yourself what a, b, and c are. In this case, a is equal to 1 because there's nothing attached to the x squared, or it's basically the exact same as 1 times x squared. So a is 1. B is equal to 3 because that's what's attached to the x. And then c is equal to 2. Okay, it's as simple as this. So I'm going to write it down here. For our x values, we're going to get that x is equal to negative 3 because that's minus b. I'm just going to copy the formula and plug in values into it. So negative 3 plus minus the square root of 3 squared minus 4 times 1 times 2 all over 2 times 1. Okay, so first I'm going to add this. I'm going to put this in the calculator with the addition symbol. So let's try that. So negative 3 plus the square root of 3 squared minus 4 times 1 times 2 all over 2 times 1. So this gave me negative 1. Okay, and now I'm going to do the exact same thing, but instead of using the addition sign, I'm going to use the subtraction sign. So if you do that, negative 3 plus minus, or just minus in this case, minus 3 squared minus 4 times 1 times 2 all over 2 times 1, you are going to get negative 2. And those are both values of x, and these are the x-intercepts of the function f of x. Okay, so it's as simple as this. We just found both values of x. Okay, let's move on to question number 2. Once again, pretty simple. We have to first declare what a, b, and c are. So in this case, a is equal to 2, b is equal to 19, and c is equal to negative 7. Once again, you have to attach the sign with all these numbers. In this case, these were both positive. That's why they're both positive here. Only c is negative, so that's why it's a negative 7. Okay, so I'm going to plug it in my calculator now. So first of all, I'm going to write it here. X is equal to, negative b is going to be equal to negative 19. So negative 19 plus minus the square root of 19 squared minus 4 times 2 times negative 7. I'm going to erase some of these arrows and make the square root sign look a bit better. And then all over 2 times 2 because it's 2a. And a is equal to 2, so 2 times 2. Plug this in the calculator, so fraction. And then negative 19 plus the square root of 19 squared minus 4 times 2 times negative 7 all over 2 times 2. That gave me a weird number. I'm going to kind of write it as the approximation of a decimal. So this gave me that x is equal to 0.355. That's my first x value. My second x value, all I'm going to do is change the sign being used between these to be the subtraction sign, because I already used the addition. So it would be negative 19 minus the square root of 19 squared minus 4 times 2 times negative 7 all over 2 times 2, and that will give me a weird number once again. In this case, it is negative 9.855. Okay, so yeah, even though they are weird numbers, this is why the formula is used. Because if it was always nice numbers, you could probably find them using some other method. But this formula or method is used because most of the time it's going to actually be weird numbers that you cannot find using any other technique. So you actually need to know this. Okay, question number 3, let's do the exact same thing. So first, let's declare what A, B, and C are. A is equal to 1 over here. B is equal to 10. No, it's negative 10. So B is equal to negative 10. And then C is equal to, once again, not 24. You have to include negative, so negative 24. Now let's put it into the formula. So X is equal to negative B is equal to 10, because if B is equal to negative 10, then negation of B is equal to 10. And plus minus the square root of negative 10 squared minus 4 times A is equal to 1. And then C is equal to negative 24. All over 2A. In this case, A is equal to 1, so it would be 2 times 1. Okay, let's put this in a calculator once again. So I'm going to set it up, but yeah, put this in a calculator. I'm going to get that 10 plus the square root of negative 10 squared minus 4 times 1 times negative 24 all over 2 times 1. This gave me 12 as my first value. Second value, I'm going to do the exact same thing, but change the sign to be a negative between them. So it would be 10 minus the square root of negative 10 squared minus 4 times 1 times negative 24 all over 2 times 1. And that gave me negative 2. Pretty simple, and those are both of your x-intercepts for this function. It is as easy as this. As you can tell, it gets repetitive once you keep doing this more and more and more. Okay, now f of last question, f of x is equal to negative x squared plus 3x plus 4. So once again, declare a, b, and c's. So a is equal to negative 1 this time because there's a negative here. B is equal to 3, pretty simple, and c is equal to 4. Okay, let's put this in a calculator. So first I'm going to write it down here. X is equal to negative b, so negative 3, plus minus the square root of 3 squared minus 4 times negative 1 times 4 all over 2 times negative 1. Okay, put this in a calculator once again. So we got negative 3 plus the square root of 3 squared minus 4 times negative 1 times 4 all over 2 times negative 1. This gave me negative 1 as my first answer for x. So x is equal to negative 1. And my second answer, I'm going to change everything, or just a sign in the middle, to be a subtraction sign. And that gave me just 4. So that is, once again, those are my x-intercepts for this question. A few exceptions to this rule. So if you actually consider what the square root is, let's say it's giving me 1 inside of it. So for example, let's say this is all equal to the square root of 1. Okay, square root of 1 is equal to 1. That means if you add 1, you're going to get one answer. And if you subtract 1, you're going to get another answer. That's why we have 2 answers in this case. Okay, but let's say in some other question, instead of the square root of 1, I got the square root of 0. Square root of 0 is equal to 0, but adding or subtracting 0 does not make a difference. In that case, you're only going to have one answer, because plus 0 or minus 0 doesn't make a difference once again. And this happens, I'm going to repeat it, but this happens when the square root inside of it is equal to 0. Because if the value is equal to 0, that means adding or subtracting it will not make a difference. Okay, and that is when you get only one answer instead of 2 answers in this kind of final answer. And then the only time you get no answers is if the square root has a negative sign in it. So let's say whatever is inside the square root gives you, I don't know, the square root of negative 1. Your calculator is going to say math error. This is because you cannot take the square root of negative 1 if you do not know what imaginary numbers are, but that's a whole different topic. So let's just for now say that the square root of negative 1 is not possible. And then if you put it in calculator, you're going to get an error. And therefore, this entire thing would not have an answer. Okay, so those are kind of the options you have. You can either get 2 answers, like we have here. You can get 1 answer if the square root was equal to 0. And then you can get 0 answers if you had a square root of a negative number, or negative x. Okay, but that's pretty much it for this video. Hopefully you understood. If you liked it, leave a like because it will help me. But that's pretty much it.